Geometry, Lesson 4.4. We're going to apply congruence postulates today and learn some new postulates for proving congruence. Short vocabulary list. We're going to learn about flow proofs. We have 4 new theorems. For the most part, we're going to work with isosceles triangle and angle-angle side. So let's begin with angle-angle side theorem. We call this AAS. If 2 angles and a non-included side of one triangle are congruent to the corresponding angles and side of another triangle, then the 2 triangles are congruent. The triangle congruence theorems that we worked with yesterday had included sides or included angles. Now we will be working with triangles that do not have included sides or angles. So it says if 2 angles and a non-included side. So let's look at these triangles. We have angle A and angle C, which are congruent to angle X and angle Y. And we have side length AB, which is congruent to XY. But the side is not in between the 2 angles. It's not AC or XZ. So in your notes, be sure you make some kind of notation about whether sides are included or not included. Something new that's being introduced is this concept of using flow charts to do theorems. I'll review these with you, but won't be assigning any homework. I want you to be really comfortable with doing proofs before we go into anything like this. But let's use the same 2 triangles. We have triangle ACB is congruent to triangle XZY. We begin by saying that angle C is congruent to angle Z, and that is our given. We also know that angle A is congruent to angle X, and that is in our given. And we had a third concept, segment AB is congruent with segment XY. So all these 3 things are given, and they would have been in the first step of the normal proofs that we do. The first 2 angles, the arrows show, go to a third concept, and this is a third angle. And we can prove the third angle by AA postulate. Okay? So remember that that postulate says that if you have 2 angles congruent in 2 sets of triangles, then the third will be congruent. Now, the concept of angle A is congruent to angle X and AB congruent to XY also leads us to, with the information of the third angle, that these 2 triangles are congruent by angle side angle. Example 1 is example of one of those flow charts. They're using a triangle here. It has OM, this line segment in the middle of the triangle, and they're telling you that it's a perpendicular bisector of LM or LN, which is going to create 2 equal line segments. They want you to prove that triangle LON is isosceles. And remember that isosceles is a triangle that has 2 sides that are the same length and 2 base angles that are the same measure. So they begin by stating the given, that OM is a perpendicular bisector of LN. This concept flows to the point that M would be the midpoint of LN. You could see that visually. The definition of the bisector, because of the definition of bisector, and then we can state that LM is congruent to NM, which is the definition of the midpoint. So all of these things involve this line segment LN. From the given, we can also determine the two angles that the perpendicular bisector creates. So angle LMO and angle NMO are right angles. That is the definition of perpendicular. Now, because they're both right angles, we can state that they're congruent and that the two triangles are congruent to each other by side, angle, side. But we're not done because we're trying to prove that this is isosceles. So we can now also state that OM is congruent to OM because of reflexive property. And our last segment, OL, our last segments, I should say, OL and ON are congruent because of CPC-TC. And now you have the whole picture for our isosceles. You have the two angles that are congruent, and then you also have the two sides that are congruent, and you can, as your last step, state that triangle LON is isosceles by definition of isosceles triangle. This leads us to the isosceles triangle theorem. If two sides of a triangle are congruent, the angles opposite those sides, the base angles of the isosceles triangle, are congruent, and that's theorem 4.2. Let's take a look at a proof that uses this isosceles triangle theorem. The isosceles triangle X, Y, Z, they're already telling you it's isosceles, and they're telling you that the two line segments XY and XZ are congruent. We want to prove the two base angles, angle Y and angle Z. They begin by making the statement that XY is congruent to XZ from your given. And then they say that you can draw XW. So you're allowed to draw XW, and it creates a situation that bisects the bottoms or base line of that triangle, which is YZ. You can use the protractor postulate to draw lines anytime you need to. This leads to angle YXW being congruent to XZXW, which is because of the definition of angle bisector. And now we can say that XW is congruent to XW, reflexive property. And we have now everything we need to state side, angle, side, and our congruent triangles XYW and XZW. Now we can look at our last pieces that we need to solve to prove, and we can state now that angle Y is congruent to angle Z because of CPC-TC. So this is a fairly common proof. These same steps will be used in many proofs. And be sure to remember that whenever you're setting something congruent to itself, that this is reflexive property. Now there's a converse of that theorem, and this states if the two angles of a triangle are congruent, the sides opposite those angles are congruent, and the triangle is isosceles. So the previous theorem stated the two sides and then the angles. The converse states the two angles and then the side. Let's move on to the next theorem, and I'm calling this, it didn't have a name, but I'm calling it the equilateral equiangular triangle theorem. We've talked about this in class. A triangle is equilateral if and only if it is equiangular. So equilateral triangles will also have equal angles. Equiangular triangles will also have equal sides. Let's take a look at example 2, and I wanted to point out this shape that they're showing you. This is going to be one of those common shapes you use for proofs. And what it is two triangles that overlap each other, and I wanted to show you, if you separate the triangles, you can see that BC is shared by both triangles. And I urge you, when you have these types of overlapping drawings, to redraw the figures so they're much easier to see. Let's move on to the actual proof of these. So we have the original drawing, and now we have our triangles. And given that angle A is congruent to angle D, and angle ABC is congruent to angle DCB. So there's A and D with one arc, and ABC and DCB with two arcs. Prove that this longer side, AC, is congruent to DB. So we have our given in our first statement. And the next thing we can prove, we already have two angles. So if you look at the original drawing, remember that BC is congruent to BC. So our second step, it says BC is congruent to CB, and they're saying that because, remember, you have to name your triangles or your figures in corresponding order. So this triangle, if you note, has one arc and then two arcs. This one has one, then two. So we go ABC, DCB. So this would be BC, and that would be CB. Reflexive property. And now, using the two angles and the side that we just declared congruent, we can say that triangle ABC is congruent to triangle DCB by angle side. And we can pick the piece out that we need now, this AC and the DB, declare them concurrent by CPC-TC. Your homework is on page 169 through 171. It's numbers 1 through 13, 17, 19 through 20, number 28, and there's an extra credit problem on the last slide. Let me show you a few problems that are similar to your homework. Number 14, use the figure to write a two-column proof of angle side. So we're given these two triangles, and angle A is congruent to angle X, angle C is congruent to angle Z, and segment AB is congruent to segment XY. We already have two angles and a side here. It's not an included side, but this is the actual proof for the theorem. So we're going to prove that triangle ACB is congruent to angle XZY. So the first thing that we do is we place our first statement in there from the given, and then we put what we're going to prove in our proof. Second step, because we already had two angles, we can now state the third angle. So we can say that angle B is congruent to angle Y. And that's pretty messy. I'm going to do something else to just show you another idea that you can use for your angles to also state them congruent, make them look different. So angle B is congruent to angle Y, and that's by AA postulate. Now we have all of our angles proved. We have one side proved. We can state by what we've learned, that angle ACB is congruent to angle XZY, and that is because of the AA angle side theorem. Okay? Find the measures of the four numbered angles. Let's take a look at this triangle, and we see we have several triangles, some inside the triangles, but I wanted to note that this larger outside triangle is isosceles. The sides are congruent, and this inner triangle is also isosceles. We have two angles here that have variables, so let's go ahead and solve those variables first. And one of the things we note about these angles is that they're supplementary. So they equal 180 degrees, and we can add these two angles together to equal 180 degrees. So x plus 15 plus 2x plus 15 equals 180. Combining like items, 3x plus 30 equals 180, and x equals 50. Let's take our angle with 2x plus 15. 2x plus 15 would be 2 times 30, which is 2 times 50, which is 100, plus 15, which is 115. And our x plus 15 will be the measure of angle 4, because the measure of angle 4 is a base angle of an isosceles triangle. These will be equal, and x plus 15 is 65. So this angle will be 65 degrees. And even though sometimes with these lessons they desire you to use your most recent postulates or theorems to solve these things, sometimes it's easier. We know that these are sup angles right here. 180 minus 65 is 115. That's another way that this can be solved, but we have already solved that with our algebra. Let's take a look at the measure of angle 1. We have a triangle right here. We already have 65 and 65 in our triangle. That means that we only have one other angle to solve. So 180 minus 65 minus 65, or 180 minus 130, is 50 degrees, and that is the solution of angle 1. Okay, now we're going to take a look at the measure of angle 3. The measure of angle 3 is an angle that's part of a larger isosceles triangle, and these two angles are congruent to each other. We know that we have supplementary angles here, so I went ahead and filled in what the measure of this angle is. But we have up here an exterior angle, and this angle is 100 degrees, and it's exterior to this larger isosceles triangle. So one of the things we can look at is we can say that these two angles have to add up to, the two angles for number 3 must add up to the 100 degrees for the exterior angle. So the measure, 2 times the measure of angle 3 will equal 100, and that's divided by 2 angles, so the measure of angle 3 is 50. And now we can solve angle 2 by subtracting 50 and 115 from 180. So 180 minus, oh, and I did a little different on here. It still came out, but I found a shorter way. 180 minus 50 minus 115 equals 50 degrees. I think I started here by actually using this angle, this exterior angle, and using those as remote angles, and it still worked. So, different ways for solving the same things. I encourage you, if you can fill in as many angles as possible first, it'll make it easier to just subtract from 180 and to go from there. Let's take a look at number 27 from the homework. This is a drawing that we're really familiar with. We're given that angle I is congruent to angle L, and that HJ is congruent to KJ. Let's move that to the given, and let's also put that our prove, which we're proving that triangle HJI is congruent to KJL, is in our third step. And let's take a look at what we need to prove. Right now, taking a look at this, most of you should be thinking, right away we can mark vertical angles equal, and that is the next step. So angle IJH and angle LJK are congruent because of vertical angles. Be sure that you call these out in the corresponding order. And we now can state that these two triangles are congruent by angle, angle, side. Here's the extra credit problem. Find the measure of each numbered angle. Let me know if you need any assistance. Have a great day.